Good morning, my dear students. Namaste. The previous two videos, due to heavy rains in my place, it is giving somewhat difficulty while I am shooting the video. But today, this is the third part. Actually, part 2. In the previous part 2, it is a 12 minutes video. We say it is part 3, it is connected with that one. Okay, na? Vectors. In the first video, I taught the definition of a vector. And the next one is types of vectors. Equal vectors, parallel vector, collinear vector. What is the difference between parallel vector and collinear vector? Very clearly in the second video, part 2, I taught you, I clearly explained. Now, the last 1 minute, there about co-initial vectors, there it is due to some reason, it is cut out. Okay, now I continue it. The fourth type of the vector is co-initial vectors. In the name itself, we can understand co-initial, same initial, for two or more. You see, two or more vectors are said to be called as co-initial vectors if they have the same initial point. You see, suppose A is initial point, AP is a vector, A bar. This is A bar, AB bar also. Two are the notations. AQ is a vector, B bar. With a single letter B bar, it is a notation bar, AQ bar. And it is AR bar, it is a C bar. Okay, na? A bar, B bar, C bar. Or otherwise, AB bar, AQ bar, AR bar. Having the same initial point. So, they are called as a co-initial vectors. Very simple. Having the same initial point. And the length also may be equal or not equal, irrespective of their magnitudes. Okay, na? Whatever their magnitudes may be. And directions also. But the condition is only same initial point. A, P. For AP, A is initial. AQ, A is initial point. Here, initial point is A itself. Then they are called as co-initial vectors. Similarly, negative of a vector. Next. Negative of a vector. Negative of a vector is separately not be there. It is about a given vector. Negative vector not. It is negative of a vector. If a vector is given, for that one we can find the negative vector. But it is not separate. Separately it is not defined. If a vector is there, for that one we can find the negative vector. The negative vector of a given vector A bar is a vector, first of all, is a vector whose magnitude, observe, whose magnitude is same as the given vector. Suppose given vector is having 10 units, then negative of a vector is also having the 10 units. But the direction is opposite to the given vector. A, B bar, A to B is direction. Then B to A is opposite direction. So, B A bar here. B A bar is the negative vector of given vector A B bar. Okay, na? Very clear. AB distance, length, BA distance are same. I can draw the diagram. It is AB bar. Okay, na? Next, it is BA bar. Okay, na? Or otherwise, you see that it is AB, a vector is there. Then it is also AB. Okay, na? It is in the opposite direction. Okay, na? Or clearly you take this one. A B bar is there. For that one, suppose it is 10 units. It is also 10 units length. It is A to B, but it is B to A. Reverse, opposite direction, not same direction of 180 degrees. Okay, now here also 180. You may confuse. You leave down. You take this one more. AB bar is a given vector whose length is 10 units. But BA bar is also having the same length, same magnitude, but the direction is opposite. Then this is called as BA bar. The negative vector of given vector AB bar is a BA bar, where BA bar is equal to minus AB bar. We may write it as a minus. Minus if the initial point and terminal points interchanged. The place of initial terminal point, in the place of terminal initial point, then we get a sign, a different sign, plus minus, okay, or minus plus. This is one concept. Next, unit vector. It is also not separate unit vector. Unit vector along a given vector. This is important. Along a given vector. In the direction of given vector, parallel to given vector, like that we may ask. The unit vector along a given vector is a vector. First of all, is a vector. It is a vector. Is a vector containing. It is containing unit length. This is important. First of all, unit vector along a given vector in the direction of given vector, parallel to given vector, is first of all a vector, but having unit length. And the direction is same that of given vector, not opposite, same that of given vector. For example, I will draw the diagram here. Observe this. Suppose is a given vector a B bar. It is containing 1, 2, 3, 4, 5, 6, 7, 8 units length is there. You see, here is 1 unit, 2 units, 3, 4, 5, 6, 7, and this is 8. It is 1 unit length. Direction is same. Same direction, the same direction, A to B. This A, it is called as B1. A B1 is a unit vector. Why? Because having unit length and the direction is same. Here also B1 B2 is a unit vector. B2 B3 is a unit vector. Like that. Okay, then B7 B is a unit vector. But very clearly, the vector is there. Its length, whatever it may be, in the same direction or parallel to the direction, same direction, parallel. The unit length, parallel unit length, I will clearly add. This is a vector. It is a 1 unit length, same direction. Okay, na? Same direction, 1 unit length. It is called a cap. Suppose A bar is a given vector. A B bar. A B bar is singly, it is A bar. Then A cap is notation. A cap is unit vector and it is defined as A bar by mod A bar. Okay, na? A bar by mod A bar. Wait. Try to understand it. Again, I will tell clearly. You see, suppose PQ is a vector. It is containing 5 units. 1, 2, 3, 4, and 5. Okay, now direction is PQ bar. Let it be R bar. Singly with single letter R bar. PQ bar, of course. What is the unit vector? Unit vector along r bar is equal to r cap. It is the notation r with cap, not bar, not arrow bar. It is cap, and it is nothing but r bar by modulus r bar. Modulus of r bar means very simple. Modulus of r bar means where modulus of r bar is length of, it is length of vector r bar. Okay na? It is the length of magnitude. Magnitude of r bar is denoted by modulus of r bar. You see, r bar by modulus of r bar. R bar means a vector. It is containing both the magnitude and the direction. Direction is there. Along with the direction, magnitude is there. That magnitude divided by its magnitude. So we get 1. To try to understand it clearly. R bar is a vector. Any vector means two concepts are there. One is its length and direction. Length is divided by, it is also length. Modulus of r bar is its length. If we divide with the same number, 10 by 10, 5 by 5, like that, we get 1. And the direction also is there. 1 unit direction. So that is by definition, it is r cap, unit vector. So any vector x bar is there. What is a unit vector means? X cap. What is x cap means? X bar by modulus of x bar. Y bar is a vector. What is the unit vector along y bar? What is the unit vector along in the direction of y bar means y cap, where y cap is equal to y bar by modulus of y bar. P bar, p cap means p bar by modulus of p bar. A bar is a given vector. A cap is its unit vector. A cap is equal to a cap by modulus of a cap. Okay, Nanda? Like that. I will write here some more. It is suppose x bar is a vector. Then x cap is unit vector. X cap is x bar by modulus of x bar. Y cap, y bar by modulus of y bar. P cap is a p bar by modulus of p bar. Okay, now? Right. Yeah. Okay. Now we are going to explain the 7th type of vector, that is zero vector. Okay, now? Zero vector. The zero vector is not zero. The zero vector means whose initial point and terminal points both must be same. Both are coincident. Okay, now? That is AA bar, BB bar, PP bar, CC bar, DD bar. Here A terminal point as well as initial point. BB bar initial point as well as terminal point. PP bar. Then it is called as a zero vector or null vector. Zero or null vector. We may call as both ways. Okay, now? What it means? The null vector or zero vector means is a vector in which or whose initial and terminal points are same or coincident. Okay, now? Here, one doubt is there. We may feel that zero vector means its magnitude is 0. Not that one. Suppose A is a vector, a point. A particle, a body starts its motion from A. So A is the initial point. It takes a diversion at B to reach C. It is 4 points, it is 5 units length. From A it starts the motion and at B after some time 4 units distance is covered and it takes a diversion and covers 5 units length, it reaches C point. And again it takes some diversion and it covers 6 units distance, reaches D point. And again it takes diversion and it covers 7 units length, just like you assume. And again it reaches at the same point A. Here what is the displacement? Displacement, what is displacement? Displacement, or otherwise you see A to A only. Okay na? A is the starting point, A to B, B to C, C to D, D to again A. The particle or the body or anything, it is starting from the point A, at B takes a diversion, at C again takes diversion, at D takes diversion and reaches the same point A only. So here terminal point is A, initial point is A, so A bar. But here is length is there, 4 units, 5 units plus 6 plus 7, okay na, 13 plus 9, okay na, 22 units length is there, 22 units length is there, even though the terminal point, initial points are coincident, are same. So it is called as a zero vector or null vector. That means its length is not zero. Some length is there. Let it be. It is a different one. Again we will discuss. You try to understand that zero vector means initial point and terminal points are same. Okay now? Here the displacement of the body, displacement of the thing, displacement of the particle is A to A only, not AD or AB or AC. A to A only. At this case, it is called as a zero vector. Okay, Nana? Right. Now, 7 types of vectors are finished. Equal vectors means any 2 or more vectors are said to be equal vectors means their magnitudes and direction both are equal. AB bar, CD bar, PQ bar having the same length, that is equal vectors. And again parallel vectors. Parallel vectors means 2 or more vectors are said to be parallel vectors means their lines of directions are parallel. Their lines of directions, not directions, their lines or directions are parallel. Whatever the magnitude may be, irrespective of their magnitudes, is parallel vector. Collinear vectors. 2 or more vectors are said to be collinear vector means those vectors are lying on the same line or whose directions are lying on the same line, either in the same direction or opposite direction also. Okay, na? That is collinear vectors. Next, coinitial vectors. Very simple. Some vectors having the same initial point. AB bar, AC bar, AD bar, AP bar, AQ bar. A is common. So it is coinitial vectors. Next, negative of a vector. AB bar is a given vector. BA bar is a negative vector. PQ bar is a given vector. QP bar is a given vector. Negative vector. LM bar is a given vector. ML bar is a negative vector. Okay na? AB bar, BA bar. But BA bar is nothing but minus AB bar. PQ bar is given vector. QP bar is a negative vector. Negative of the given vector. QP bar is nothing but minus PQ bar. Already we know. Unit vector. Unit vector is a vector along a given vector. That is A bar is a given vector. Then what is unit vector? A cap is equal to A bar by alias of A bar. Yeah. Next, zero vector. Zero vector is a vector whose initial and terminal points are coincident. Notation is a zero bar. You say it is zero bar. Somebody may tell it as O bar, but not O. It is zero bar. You mention it is a zero bar. Yeah. A bar, BP bar, PP bar, like that. Okay, now? These are the 7 types of vectors. Now, we are going to solve the exercise 10.1. Okay, Dada? Yeah. Observe. The first one. Represent graphically the displacement Displacement. Displacement is a vector of 40 kilometers, 30 degrees east north. East north. East from north is given. Okay, now I will tell clear. Observe me. You see that? I want to tell AB distance 10 units. It is a scalar. This is a distance between A and B. Distance is a scalar. Displacement. Displacement means a body starts its motion from A to B. It starts from A and reaches B after some time. After some time covering a distance 10 units. Here distance is there and direction also is there. This is displacement. Okay na? Displacement. Okay na? Here it is a vector. Okay na? Here is very clear. Arrow mark is there, but here arrow mark is not there. Here direction is given. Here direction is not given. The distance between A and B or B and A, whatever it may be, between 2 points, the distance is only here the magnitude, scalar. Here magnitude as well as direction. Displacement. Displacement means from which point to which point. That is important. Okay na? So here the displacement is from A to B. Okay na? This is a displacement. Displacement. Okay na? It is a vector. Purely it is a vector. But it is a scalar. Now we'll come to the problem. What is the problem? Always you mention the like this one. Always right side is east, opposite side is west, and upside is north. This is south, and it is northwest, northeast. It is called as northeast, and this corner is northwest, and this corner is southeast, and this is southwest. Okay now? Now we come to the point. We are given graphically, we have to draw a diagram by using the data. 40 kilometers, 30 degrees east from north. This is north. You see and observe it. This is north. From north to east, like this. 30 degrees. From north to east, 30 degrees angle. A line is there, whose length is 40 kilometers. This is O, side is P. So OP is a vector. The direction is from O to P. That is north, east from north, 30 degrees. Given is there. Your direction is given clearly. And 40 kilometers is the length. Okay now? Like this we have to mention. That is the first one. Next, second one. Classify the following measures as scalars or vectors. Yeah. Whether it is a scalar or vector, we have to mention. You see. Second one. Observe me. The first one is 10 kgs. A weight is, the measurement of weight is kgs. Okay, na? So 10 kgs only weight is there. Weight that is 10 kgs, length, distance, volume, breadth, area, all are scalars. So measure, here the measure is 10 kgs is a scalar. Okay, now next second one. What is second one? 2 meters northwest. 2 meters northwest. Here also the same thing. Here also this is north and where it is northwest. This is west, east, south. This is vector. Okay, now northwest very clearly I mentioned here like this. Okay, now here it is very clear. 2 meters. 2 meters length is there. Direction also is there. Northwest direction. Northwest direction is there. So both are there. So it is a vector. Okay, now next. Don't be confused. 2 meters length is there. And northwest. Northwest means it's a direction. So directional and meters length is there. Magnitude. So it is a vector. Third one, 40 degrees, simply 40 degrees is given. Suppose 40 degrees means it is a scalar. Why? Because we are given only that one measurement, degrees is given. Degrees is given. How much degrees are there? Suppose OP line, suppose x-axis is there, it is the horizon, it is the y-axis. Okay, now? It is a line OP. It makes only 40 degrees. But don't take OP line. You may confuse. If 2 meters and 40 degrees means it is a vector. But we are given only 40 degrees. If you see this diagram, you may confuse. Simply 40 degrees means scalar. You leave it out. Next, fourth one. We are given a fourth one. What is the fourth one? 40 watts. And fifth also I will write it. Fifth is 10 power minus 19 coulombs. These two coulombs and watts. Coulombs means it is a name of mathematician or physicist. These two measurements, watts and coulombs. These two are related with the electricity. Okay, now, what is a measurement of flow of electrons which causes light? Okay, now, how much of light it gives? That is one different measurement. Okay, it is purely physics lived out. The watt and coulombs both related with the electricity. That is purely, fifth one is purely the flow of electrons, a set of flow of electrons. This is which causes the light only. Okay, now both are simply measurement. So these are also scalars. Okay, now next the last one is 20 meters per second square. Yeah. Sixth one. 20 meters per second square is there. Second square is there. Second square. Okay, na? Second square. 20 meters second square. Here 20 meters per second means 20 meters per second means it's a velocity. 20 meters per second square is there. Is acceleration. Acceleration is a vector. It is a vector. Okay, Nana? It is here is there. Meter per second square is a 12. 20 meters. 20 meters first. The next is again 20 meters. It is increasing. It is a vector. Okay, Nana? Right. Next, third one. Third one is the classification. Classify the following as scalars in the same concept as the two. Time period. We are given a time period. Time period. This is 1. Time period is also a scalar. Distance, already we discussed. Distance is also a scalar. Force is a vector. How means, suppose at a point a stone is there. This is a stone. By using with the help of one rod or a stick, with the stick we use some force to lift or to displacement a stone from A to B. The same stone is replaced from one place to another place. Here it is force. Some magnitude is there towards our hand to on stone through the stick or rod. So that is called force. So here is magnitude as well as direction is there. So it is a vector. And fourth one is velocity. We know it now. Velocity is a vector. It is simply a vector. You know it. Vector velocity means not speed. What is the speed of a car? Means 60 kilometers per hour. Velocity of a car means from which place to which place. There is a direction. You know it well, very clearly. So velocity is a vector. The fifth one, last. Fifth one is work done. Work done. Work done is a scalar. In this example, I will clear. By using some force through a rod, a stone is lifted and displaced from one place to another place. Here some work is done. That work is done. Okay, now, so that what amount of work is done means it is you can understand easily. In the physics it will come. That work, amount of work, but force is there from place to place, it is a different one. Work done is a scalar. Okay, now, right. Like that we can solve the problems. You see it. Yeah.